Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Dear students, this lecture is for grade 8, subject chemistry. And in this chapter, we will discuss the remaining topics of chapter number 4, which is structure of molecules. This is my 25th lecture, and I am your lecturer, Mrs. Saira Jamal. Example 4.6, drawing electron dot and cross structures for simple covalent molecules containing single covalent bonds. So we have to draw the structure of molecules, and which structure? Electron dot and cross structure. Electron dot and cross structures are also called Lewis structure. So you can say that to draw electron dot and cross structures for simple covalent molecules containing single covalent bonds, or we can also call it Lewis structure of covalent compounds or covalent molecules. The first molecule which we have to draw the structure is methane. That is a major component of natural gas. Methane is present in large amount in natural gas, which is also called sweet gas. The problem solving strategy is, first of all, we have to decide from the formula CH4 that which is the central atom. An atom that contributes more electrons for sharing is the central atom. Show its valence electrons by dots. Note the number of electrons one needs to complete octet. If number of electrons needed equals the other atoms, each atom will form a single covalent bond. In this case, you can see that carbon has 4 electrons in the outermost shell, and it needs 4 more electrons to complete its octet. But hydrogen has only 1 electron, and it needs 1 electron to complete its duplet. So arrange other atoms around the central atom. Connect the central atom by a single bond. Use cross to represent electrons of the other atom. We will represent the electrons of carbon by dots, and those of the hydrogen atoms by cross. Check whether the arrangement of electrons satisfies the octet rule or not. Solution of structure of methane or electron dot and cross structure of methane. Carbon has 4 electrons in the outermost shell. One more important thing which you have to keep in your mind is that while drawing the covalent structure, you have to draw only the outermost shell of that atom, like only the outermost shell of carbon, the outermost shell of hydrogen. While drawing the electron dot and cross structure for the ionic compound, we have to draw all the shells. But for covalent compound, we will draw only the outermost shell. So carbon is the central atom because it contributes more electron, or it share more electron. It share 4 electrons, while hydrogen will share only one electron. So carbon has 4 electrons in the valence shell and needs 4 electrons to complete its octet, while hydrogen has only 1 valence electron and needs 1 electron to complete its duplet. So carbon can form 4 single bonds with 4 hydrogen atoms, and carbon is the central element. You can see here that carbon is the central element, and we will represent the electrons of carbon by a dot. So 1, 2, 3, 4. There are 4 dots, and the electrons of each hydrogen atom by crosses. This is the electron of this hydrogen atom, electron of this hydrogen, electron of the third hydrogen, and electron of the 4 hydrogen atoms. So you can see that all these 4 hydrogen atoms shared one electron with the carbon atom and will form 4 single covalent bonds with the carbon atom. So let us see that either the octet is completed or not. So this is the outermost shell of carbon, and let us count the number of electrons: 2, 3, 4, 5, 6, 7, 8. Yes, the octet of carbon is completely filled now, and that of hydrogen duplet is also completed. Two electrons are present in the outermost shell of each hydrogen atom, so their duplets are completely filled. Connect the atom with a dot and across. You can see we connect the atom of hydrogen and that of carbon with dot, that is the valence electron of carbon with the cross of hydrogen. Dot of carbon and cross of hydrogen. Dot of carbon and cross of hydrogen. So connect the atom with a dot and a cross with the other atom. The structure of methane or Lewis structure of methane, we can also represent it in this form. The dots of carbon, which is the central atom, and the crosses of four hydrogen atoms which are attached or which surround the central carbon atom. And then by sharing these electrons, you can see four single covalent bonds are formed by carbon atom with four hydrogen atoms. The covalent bond we represent by dashes or a dash line. Second example is of water. We have to draw Lewis structure or electron dot and cross structure for water molecule. So you know that oxygen is the central atom. Oxygen has 6 electrons in the valence shell and it needs 2 electrons to complete its octet. While hydrogen has only one valence electron and it needs only one more electron to complete its duplet. So oxygen can form two single bond with two hydrogen atoms. Oxygen is the central atom and arrange the hydrogen atoms around oxygen and connect them by a pair of electrons, one dot and one cross. Now you can see this central atom is of oxygen. It has 1, 2, 3, 4, 5 and this cross 6. 6 electrons in its outermost shell. The crosses are the electrons of central atom, that is oxygen, and the dots are of hydrogen. So this is not compulsory that you have to represent the electrons of central atom with dots or cross. It's up to you if you want to represent it with cross or with dots, no problem, both will be correct. So these crosses are the electrons of the oxygen, which is central atom, and the dots are the electrons of the two hydrogen atoms, which they share with the one electron of oxygen, and then in turn will form two single covalent bond with oxygen. So this is one single covalent bond with oxygen, and this is the second single covalent bond of hydrogen with oxygen. This Lewis structure or electron dot and cross structure of water can also be represented as, you can see dot and cross, and these are the electrons of oxygen which does not participate in bond formation, and they are called lone pair electrons, while these two dot and cross are called bond pair electrons. So the lone pair electron will be represented as such, while the bond pair we will represent with solid line which are called dash. Coming towards the next topic, that is self-assessment exercise 4.6, which is same like this drawing electron dot and cross structure for the simple covalent molecules or Lewis structure of the simple covalent molecule. Example is of ammonia. Ammonia, you can see it has nitrogen and three hydrogen atoms. So ammonia will be the central atom. It has 1, 2, 3, 4, 5, 5 electrons in its outermost shell, and it needs three more electrons to complete its octet. So in order to complete its octet, hydrogen has only one valence electron and needs one electron to complete its duplet. So each three hydrogen atom will share one electron with the nitrogen atom, and then in turn will form three single covalent bond. This electron pair is the lone pair electron, which does not participate in bond formation, and the remaining three electrons will participate in bond formation. Arrange the hydrogen atom around nitrogen and connect them by a pair of electron dot and cross. You can see we connect the two atoms by these electron dot and cross, dot and cross, dot and cross. The two atoms are connected. Nitrogen and hydrogen are connected with each other through electron dots and cross structure, which are also called Lewis structures. We can also represent the Lewis structure of ammonia by this. Nitrogen has 1, 2, 3, 4, 5 electrons in its outermost shell, and it needs three more electrons. So those three electrons will be shared by the three hydrogen atoms and then will form three solid covalent bonds or single covalent bond, which represent with the solid line. And these two electrons are the lone pair electron, which does not participate in bond formation. B part is carbon tetrachloride CCl4. Carbon has 4 electrons in the outermost shell, as I told you in the previous example, and it needs 4 more electrons to complete its octet, while chlorine has 7 electrons and needs 1 more electron to complete its octet. So as chlorine needs less electrons, so chlorine will be the side atom and carbon will be the central atom. So you can see the dots of the dots of carbon atom 1, 2, 3, 4. These 4 are the electrons of carbon atom which are present in the outermost shell, and chlorine has 1, 2, 3, 4, 5, 6, and this cross 7. 7 initially chlorine has 7 electron and 1 electron it will share with the carbon atom, hence in turn will have 2, 3, 4, 5, 6, 7, 8 electrons in the outermost shell. Same is for all these cases. Same is for all these 3 cases that they will share electron with each other and will form 4 single covalent bonds. So carbon can form 4 single bond with 4 chlorine atoms. Carbon is the central element. Connect the atom with a dot and across. You can see we connect them with a dot and across, and this is the Lewis structure or electron dot and cross structure of methane. We can also represent it by carbon in the middle and dots, 4 dots at 4 sides, sharing by 4 chlorine atom, which also have 1, 2, 3, 3 lone pair electron, which does not participate in bond formation. And those covalent bond we can represent by solid lines. Silicon tetrachloride structure is same like that of the carbon tetrachloride because carbon and silicon both belong to group number 4 of the periodic table. So silicon has 4 electrons in the outermost shell and it needs 4 electrons to complete its octet, and chlorine has 7 valence electrons and needs 1 electron to complete its octet. So silicon can form 4 single bond with 4 chlorine atoms. Carbon is the central element. Connect the atoms with a dot and a cross. You can see in this case silicon is the central atom and it is surrounded by 4 chlorine atoms. Those 4 chlorine atoms, the first one, and you can see 1, 2, 3, 4, 5, 6, 7. 7 electrons are present in the outermost shell of each chlorine atom, and they will share one electron with the silicon. Then enter the outermost shell of silicon is completely filled. It has 8 electrons in the outermost shell. So this is the Lewis structure of silicon tetrachloride. We can also represent it with in this form, silicon having 4 chlorine atoms attached at 4 sides and shared one electron with silicon and form single covalent bond, 4 single covalent bond, which we can also represent by the solid lines or solid dashes. Hydrogen sulfide, sulfur will be the central atom because sulfur needs 2 electrons to complete its octet, while hydrogen has 1 electron in its outermost shell and it needs 1 more electron to complete its duplet. So hydrogen has only 1 valence electron and needs 1 electron to complete its duplet. So sulfur can form 2 single bond with 2 hydrogen atoms such as a central element. Arrange the hydrogen atoms around sulfur and connect them by a pair of electrons, one dot and one cross. So you can see sulfur has atomic number 60 and it has 6 electrons in the outermost shell. You can see 2, 2, 4, 5 and 6 electrons in the outermost shell, and it needs 2 electrons to complete the outermost shell or octet of the sulfur. So you can see each hydrogen atom will share one electron with the sulfur, and as a result, 2 covalent bond will formed. You can see the Lewis structure of this hydrogen sulfide. Hydrogen has one electron or one crosses, while sulfur have 1, 2, 3, 4, 5, 6 electrons in the outermost shell, and they will share electrons with each other, and then in turn will form this solid molecular structure, this is also called Lewis structure. Then example 4.7, which is the last example, drawing electron dot and cross structure for simple covalent molecule, but in this case having multiple covalent bond, not single covalent bond, multiple covalent bond. So first example is of carbon dioxide. You know that carbon will be in the center and it has 4 electrons in the outermost shell, while oxygen has 6 electrons in the outermost shell. So carbon need 4 electrons and oxygen need 2 electrons to complete the octet. So they will share electron with each other. You can see two pair of electrons are shared between the carbon and oxygen atom. So due to those 4 electrons and 2 pair of electrons, double covalent bond will form between carbon and oxygen at both sides. With this oxygen atom, carbon will form double covalent bond, and with this oxygen also carbon will form double covalent bond, and then in turn will have 8 electrons in the outermost shell of each atom. Carbon has 4 electrons in the outermost shell and needs 4 electrons to complete its octet. Oxygen has 6 electrons in the outermost shell and needs 2 electrons to complete its octet. Carbon needs 4 electrons and there are only 2 oxygen atoms, so it will share its 2 electrons with each oxygen atom. Connect atom with a dot and a cross. Second part is hydrogen cyanide, HCN. In HCN, hydrogen has 1, carbon has 4, and nitrogen has 5 electrons, and carbon need 4 electrons, hydrogen need 1 electron, and nitrogen need 5 electrons to complete its octet. So carbon is in the center. Carbon needs 4 and nitrogen needs 3 electrons. So carbon share 1 electron with hydrogen, only 1 electron with hydrogen, while the remaining 3 electrons it will share with the nitrogen atom to form a triple covalent bond, and this will satisfy octet rule. You can see hydrogen has 1 electron, carbon has 4, and hydrogen in this is nitrogen. Nitrogen has 5 electrons, so when they combine together, they will form hydrogen cyanide having, you can see it has 6, 7, 8, 8 electrons in the outermost shell. So the octet of carbon is completely filled. Next part, as I told you, carbon disulfide. You can see carbon having 2 sulfur group at both sides, and carbon will be the central atom. Again, it has 4 electrons in the outermost shell, and it will gain or lose those 4 electrons to complete its outermost shell. So carbon disulfide, sulfur has 6 electrons in the outermost shell and needs 2 electrons to complete its octet. Carbon has 4 electrons and needs 4 more, but there are only 2 sulfur atoms, so it will share its 2 electrons with each sulfur atom. So each carbon will share 2 electrons with the sulfur atoms. It will form double covalent bond with sulfur. You can see in this case carbon has 1, 2, 3, 4 electrons in the outermost shell, and sulfur has 1, 2, 3, 4, 5, 6, 6 electrons in the outermost shell. It needs 2 electrons to complete the octet, while carbon needs 4 electrons to complete its octet. So carbon will share 2 electron with this sulfur and 2 electron with this sulfur, and then in turn will form double covalent bond. So you can see in this case sulfur is making double covalent bond with carbon, and then in turn double covalent bond with another sulfur. Nitrogen molecule. Nitrogen has 5 electrons in its outermost shell, and it needs 3 electrons to complete its octet. So each nitrogen contributes 3 electrons and form triple covalent bond. And you can see here that each nitrogen is sharing 3 electron pairs, and then in turn, due to the presence of these electron pairs, they will form the triple covalent bond. So this was all about the formation of the covalent bond or covalent bond formation between the covalent molecules or the non-metals, and we discussed more the examples 4.6, 4.7, and self-assessment exercise 4.6 and 4.7. So this was all about the structure of molecule formation. In 4.6, we explain the electron dot and cross structure for simple molecule which has single covalent bond. But the self-assessment exercise and in example 4.7, we discussed about the how each atom will complete its octet by sharing electrons, and then you know that if one electron pair is shared between two atoms, single covalent bond is formed. If two electron pairs are shared between two atoms, then double covalent bond will form. And if three electron pairs will share between two atoms, then triple covalent bond will form. So depending upon the number of electrons or depending upon the atom which come closer to each other, how many covalent bonds they can form. In this case, we can see carbon is making double covalent bond with each sulfur. Double covalent bond with this sulfur and double covalent bond with the second sulfur. In hydrogen cyanide, hydrogen carbon has 4 electrons or 4 dots in the outermost shell. 3 dot it will share with this nitrogen atom, and 1 dot it will share with hydrogen atom. So carbon will form triple covalent bond with nitrogen, while carbon will form single covalent bond with hydrogen. Triple covalent bond for nitrogen and carbon, and single for carbon and hydrogen. So the first example is of carbon dioxide, and carbon dioxide again is a covalent compound. Carbon will be in the middle and the two oxygen atom at the side. So carbon will share two electron pairs, two electron pair with each oxygen atom, and then in turn will form a molecule which is called CO2 or carbon dioxide, and the octet of each carbon atom is completely filled. And in this case, we can see silicon is making four single covalent bond with each chlorine atom, because only one electron is shared between silicon and chlorine. So they are making, or they will make only single covalent bond. But how many single covalent bond? 4 single covalent bond will formed by silicon and carbon tetrachloride. Carbon tetrachloride, I told you this is another form of making carbon and chlorine Lewis structure or electron dot and cross structure. Carbon we will represent with 4 dots, and then the electrons of chlorine with crosses. So you can see that the carbon is making single covalent bond with each chlorine atom. Single covalent bond with each chlorine atom. So there are total 4 single covalent bond between carbon and 4 chlorine atom, 1 carbon and 4 chlorine atoms. And in carbon tetrachloride, it is same like the methane. In methane, CH4 only, instead of fluorine, hydrogen will be there. But in this case, instead of hydrogen, the chlorine atom will make or will share electron with the carbon atom, and then in turn will complete its valency or outermost shell. And the chlorine has 7 electrons, carbon has it has 4 single bonds, and it can share electron with each other, and then in turn will form the covalent bond. This type of bond is called covalent bond, and the types of covalent bonds I told you are on different bases. Ammonia, you can see nitrogen is a central atom, and then it has 1, 2, 3, five electrons in the outermost shell, and hydrogen has one electron in the outermost shell. It will share one electron with the nitrogen atom and with the other atoms, and then in turn will form, in this case, three single covalent bonds, because these electrons are called lone pair electrons, and they will not participate in bond formation because they are already highly stable. And electron dot and cross structure in water molecule. In this case, you can see water is a central atom. It has 6 electrons in the outermost shell. It will share 2 electrons with the 2 hydrogen atom, and then in turn will form, each oxygen atom will form 2 single covalent bonds. We can also represent the Lewis structure of water by in this form. It has two electron paired, and the remaining 2 are unpaired. So 2 at the back side. It has two hydrogen atom attached with each oxygen atom, and then in turn will form 2 single covalent bonds. Each hydrogen atom will form single covalent bond with oxygen. So dear students, this was all about the covalent bond formation or raw electron dot and cross structure or Lewis structure of the following covalent molecule, if they are single covalent bond or triple or double covalent bond. Hope you understand it. So inshallah in next lecture we will discuss the next topic. So until that, take care. Allah.